Okay, good day. We'll have some additional examples also on the laws of logarithm. The other examples, or the link for the other examples, is on the description box. So let's start. We have these three laws of logarithm. Let b be greater than 0 and not equal to 1, and let n be an element of the real numbers or any real number, such that our u and v are positive. Then these three holds. Take note, if we have this is a product, then we can separate them using the addition. So log of u base b plus log of v base b. And number two, division. If it is division, then we will use the subtraction part. And if we have an exponent, then we can just put down n or write this exponent n beside the logarithm. Take note that we don't have any rule for sum. So say for example log of u plus v base b, we don't have any rule for that. And also we do not have any rule for u minus v. Okay, so take note of that. Okay, so for the first part, let's expand each expression. So these are single expressions, so we will expand this one. Okay, number one, let's start with ACS. Log of the product a times a plus 2 divided by 3. Not divided by 3, base 3. So we have this. Since this is multiplication, therefore property number 1 is applicable. So this will be our u, and this one will be our v. So we have log of a base 3 plus log of a plus 2 base 3. Okay, so we'll just have this. Okay, this one, property number 1. Okay, so let's proceed. So that's why we have this log of u plus log of v, since it's multiplication. Now we have no rule for this one, so this is now our final answer. Number 2, we have this. Take note, all of these are product in form. So 3 times x raised to 4 times y raised to 5 times z raised to 7. And we have exponents also. So we can apply properties 1 and 3. 1 because we have multiplication, property 3 because we have exponents. Okay, so we can separate this since it's multiplication, so we can have separate them by using the product, the addition. Okay, so log of 3 base 2 plus log of x to the 4 base 2 plus log of y to the 5 base 2 plus log of z to the 7 base 2. Okay, there is still base 2 here. Okay, there's base 2. Next, by property, this is the first one, property number 1, the multiplication. This one, the second line, is the property of exponents. Okay, property of exponents. So if we have an exponent, log of u to the n base b, we can just bring down our exponent here, log n, beside the logarithm. Okay, so that is why we have here 4 can be written beside this. So we have 4 log of x base 2. This one, 5 can be put here, 5 log of y base 2. And this one, we have 7 log of z base 2. So this is now our final answer for the expansion. Number 3. Okay, take note, this is, we have multiplication, 5 times x, also 6 times z. And of course, we also have division. So for the division part, we may start with the division part. Since this is division, we will use the property number 2. So the numerator, the log of the numerator minus the log of the denominator. Okay, log of u base b minus log of v base b. Okay, so this is property number 2. Next, since this is multiplication, also this is multiplication, we can use property number 1. So we have log of 5 base w plus log of x base w. And take note, since this is subtraction, please use parentheses. Okay, please use parentheses. So for this part, we have 6. So we have log of 6 base w and log of z base w. So plus, because it's multiplication. Next, we can distribute the -1 or the negative symbol, or by the rule for the negative symbol or negative sign, we have negative log of 6 base w and negative log of z base w for this part. So therefore, this is now our expansion. Next, number 4, we have a cube root. So take note, we can rewrite this one as this one. So this is an exponent. 1/3 is an exponent. Okay, and by property number 3, this exponent can be written beside the logarithm. So this is property number 3. And then take note, this is multiplication. So we can use property number 1. So addition. Okay, and we have still here the y squared. We can use property number 3. So these two can be written here beside the log. And then last is to distribute our 1/3. So we have 1/3 times log x base 4 plus 2/3. So if we multiply 2 and 1/3, we have 2/3 log of y base 4. And last example for expansion, we have this. So since this is square root, so we can rewrite this one as this. So the exponent is 1/2. So this is an exponent. 1/2 is an exponent. So the same with the other, with number 4, we'll apply property number 3. This exponent can be written before the logarithms or beside the logarithm. So we have this. And take note, we have division. So let's start first with the division. Property number 2, this will become this one, minus. So log of the numerator minus log of the denominator. And then next, since this is multiplication, this is also multiplication, we can apply property number 1. Okay, so log of 2 base 2, log of x cubed base 2, plus log of y base 2. And again, since this is minus, we'll use parentheses. So log of v base 2 plus, since this is multiplication, plus log of z cubed base 2. Okay, the next part, why this is equal to 1, because take note, we have that 1 log of b raised to x base b is equal to x. So log of 2 base 2, take note our 2 here has an exponent 1. So this is equal to 1. That is why we have 1 here. Next, property number 3, or law number 3, we can write 3 here before the log. We can bring that down. And then just copy log of y base 2. And for this part, this is an exponent, we can apply law number 3. So 3 log of z base 2. Next is we can now distribute this. So negative times positive, -3. And then we'll distribute 1/2. So 1/2, 3/2, 1/2, -1/2, and -3/2. Okay, so now let's go for the reverse. So we'll simplify the given into a single logarithm. Okay, number 1. So we'll start first here. So we can start with property number, not property, law number 3 since we're discussing the laws of logarithm. So sorry for that. So this is law number 3. So this one can be written here as an exponent of b and also 6. Okay, so we have log of b raised to 4 base a minus log of c raised to 6 base a. And since this is minus, so division, law number 2. So law number 2. Okay. And take note also that we can only apply the given laws if they have the same base. Take note that they have the same base. So here we have the same base, which is a. So that's why we can apply the laws. Okay, so this is now our final answer for number 1. Number 2, you have this. Okay, let's start first. Since we have coefficients 5, -3, or 5, 3, and 5, 3, so we can apply law number 3. So we have the exponent here, and this 3 can be written as an exponent there. That is why we have log x raised to 5 minus log 4, log y cubed base 4 plus log z base 4. So again, log of x raised to 5 base 4 minus log y cubed base 4 plus log z base 4. Okay, so actually you can answer this directly. Some of you can, I know, can answer from here up to the final answer. But for the detailed part, so we have this. Since we have this minus part, this is on law number 2, the division. So we have logarithm of x raised to 5 divided by y cubed base 4. And then just copy this one. Okay, and next, since this is addition, so this is property number 1. So multiplication. So this one, x raised to 5 divided by y cubed times this z, which is equal to this expression. So therefore, number 2 is equal to this. Number 3. So we have plus. So since this is plus, we have now a multiplication. So if we multiply this one, we'll just apply the FOIL method. 2y times 2y is 4y squared. 2y times -1 is -2y. -1 times 2y is -2y. -1 times -1 is 1. And so we have 4y squared minus 4y plus 1 on this side. So take note, we cannot do anything here. So this will be our final answer. Log of the quantity 4y squared minus 4y plus 1 base a. Number 3, what if we have this? So we have minus, so this is division, so law number 2. So this can be written as log of 25a squared minus 64 all over 5a minus 8 base 3. Take note that this is factorable, difference of two squares. Okay, difference of two squares, so we can rewrite that one as 5a squared minus 8 squared. Okay, and by the difference of two squares, this is equal to 5a minus 8 times 5a plus 8. Okay, and take note, we can cancel out 5a minus 8. So therefore, our final answer is log of 5a plus 8 base 3. And last example, we have this. So it's very long. So take note that if we have a negative symbol here, we have -1. Okay, so we can rewrite that one. We can have law number 3, so 7 raised to -1. This 4, we have this exponent 4, and this 3 exponent 3, and then 4/3 exponent 4/3. So the first part is on law number 3. Next, we have plus. So we have 2 plus. So we can apply. By the way, before that, we can rewrite this first. We rewrite first the 7 raised to negative 1. 7 raised to negative 1, so we have 1 over 7. And 8 can be written as 2 cubed. Okay, so now we have this plus, so we can have the property number or law number 1. So we will multiply 1 over 7 times this expression times b cubed. And then just copy this. And take note, we can cancel out 3 by power to power rule. 3 times 4 third. So we can cancel out 3. So what remains is the exponent 4. So we can rewrite this into this. So b cubed times the quantity a minus 3. And then we have exponent 4, then divide by 7. 2 raised to 4 is 16. Now this is minus, so it's division. So it should be here on the denominator. So we have 7 times 16. And then just multiply the denominator. We have this. So this is now our final answer. Okay, so if we change all of this log to natural logarithm ln, then of course it is also applicable. Okay, because natural logarithm is also a logarithm. So thank you for listening.